So in our last video, we talked about physiognomy and how it is the idea that you can judge somebody's internal characteristics based on their looks. And we talked about how, even though it's been sort of kicked into obscurity by the rationalists who think it's a pseudoscience, it's coming back in a big way thanks to machine learning and AI. Fireband would be so proud. Alright, so one of the papers we looked at last time was this one here. Facial recognition technology can expose political orientation from facial images, right? I just wanted to read you the abstract here. So, ubiquitous facial recognition technology can expose individuals' political orientation, as faces of liberals and conservatives consistently differ. A facial recognition algorithm was applied to naturalistic images of 1 million individuals to predict their political orientation by comparing their similarity of faces of liberal and conservative others. Political orientation was correctly classified in 72% of liberal-conservative face pairs, remarkably better than chance, human accuracy, or even a 100-item questionnaire, which only got 66%. Accuracy was similar across countries, environments, and when comparing faces across samples. Accuracy remained high, even when controlling for age, gender, and ethnicity. Given the widespread use of facial recognition, our findings have critical implications for the protection of privacy and civil liberties. So, I'm currently taking, in one of my modules, a machine learning class, and we kind of have an open-ended final project for this module. And I saw this as I was preparing for my physiognomy video, and I was like, that's crazy. What if I could replicate this study? So I tried to get a hold of their data and to rerun their code, and of course, they don't actually have the images in their data repository. They have like the facial attributes, like the tilt of the head or like the width of the mouth. They don't have the actual images, right? So I can't really like rerun their code the same way. So I decided to build my own data set. Okay, so what I did was I went onto the Congress website here. Oh, of course it's gonna open. There we go. So this website has all the U.S. Congress people, as well as most importantly, their party, right? So we have Republican, which is a proxy for conservative, and then Democratic, which is a proxy for liberal, right? And we have all these guys and gals here, and there's quite a few of them, right? There's, I don't know how many per page, 50 or 100? 100 per page, and there's 2,500 total images, so I don't know what it's like, 29 pages or something like that, or 1 to 100, I guess that'd be 25 pages, yeah. Yeah, and so I built a web scraping algorithm that goes through and gets all the photos, and then as well as the political party, and so I built my own data set to try and replicate the findings of this study. And then I trained a couple different neural nets. I don't want to get too far into the nitty-gritty. I'm going to lose my retention here, but if you're more interested, maybe DM me, or maybe I'll link the GitHub for the project in the description so you can see it. But for those who know a little bit about machine learning, we used LeNet 5 architecture. It's a pretty simple neural net. It just has a few convolution layers, some pooling, and then a classifier at the end. And it's all unidirectional. There's no like recursive weights or anything like that, or connections. So one thing to keep in mind when comparing our study to the one that was done here is that their data set was really good. It was like over 1 million, and they got it from like Facebook and dating websites, which is a much more representative sample, right? I only scraped politicians. So one assumption in our study is that politicians and their faces are the same as the general population that I'm extrapolating to, which obviously is not the case, right? Politicians are evil and their faces are evil too. So our data set might not extrapolate very well. So yeah, things to keep in mind, our data set sucks. Facial differences based on political orientation are likely very small, right? So it takes a very powerful neural net and a huge database to make confident distinctions possible, which is what you see in their study, right? They have over 1 million. And I'm sure I didn't look into the architecture that they used for their images, but it must be extremely complicated, right? Another thing to keep in mind is that our neural network only ever achieved 60% training accuracy. Or, sorry, this should say testing. Training accuracy doesn't mean anything, because you can totally overfit. So yeah, it only achieved 70% testing accuracy. And so classifications will never be very confident, especially on images that are not of politicians, right? And and the reason that might be the case is because we're not really sure what our neural net's picking up on. It might be picking up on like background things and not facial features. And so it totally could be making decisions based not on people's faces. And the third thing to keep in mind is that computational constraints prevent me from creating a larger, more powerful neural network, right? I'm running everything locally. I don't have access to like big cloud computing resources like the researchers would. So, right, we use the simple LeNet 5 architecture. So I'm just going to run these cells here, and then we're going to start seeing how well our neural net performs. And of course, Jupyter is hanging on me. So hold in here. Maybe I'll explain the code. I'm going to lose all my viewers. So we're importing different libraries. If you know anything about neural nets, I built this in PyTorch. That's what we learned in school. Here's the model. I have to specify it again. Then a few functions. And then I load the model. And then I've saved all the tuned weights from training in a different file. And I've saved it, and I'm loading them here in the PTH. And then I'm defining a predict image, so I can feed it an image file, and it'll predict on that image, then output the confidence level, right? So the confidence level, if it's 100% confidence, that means the neural net's like 100% sure that it's a conservative or a liberal. Because our neural net sucks, it like is like 51%, so it's like slightly higher than chance. So the predictions don't really mean a lot, but it's still kind of fun to see, right? And of course, this is like a proof of concept. If our database was a couple orders of magnitude larger, we would expect that the testing accuracy would increase, and we'd make more confident predictions. But I don't have access to that, so you're going to have to deal with 52% confidence. So the first image we're going to predict on is Obama, okay? So let's see. And our neural net properly classifies Obama as a liberal, right? Of course, he is part of the Democrat Party, so we are correct. And a whole 51% confidence level, which is amazing. And now we're going to see if we can get Trump correct. All right, here we go. Trump, conservative. Whew, 51%. Now, I'm going to show you two images of me. And this kind of goes to show how the neural net really isn't that good. And the prediction level is like really low, because there's two very similar images, and they predict different things. So this first image of me is a headshot I got recently. 52% confidence that I'm a liberal. It's not true. Okay. And then if we show it a very similar photo, now don't blink here, conservative. And I'm wearing the exact same thing, exact same day. The picture was taken like 2 minutes apart. And it's 50%, but it rounded down from like 50.9 or something like that. So it's 51%. So that's the issue with predicting at like very confidence levels that are very near 50%, is that it might get you one way in one picture, then another way in another picture. It's hard to say. Next up, I've got my brother, Parker. Ooh, tough luck, buddy. Looks like you're a stinky liberal. That's tough, man. Whew. Glad I'm not you. And now we've got one of my other brother, also liberal, but you know what? They always start out that way when they're young. He'll learn as he gets older. We got another one of my friend Greg here. Also liberal, unfortunately. I happen to have the pleasure of knowing Greg in person, and he is a based Sigma male, so he's conservative in real life. So the neural net's really not that good. And I've got one more here. I forgot to put it in here, but Cam, let's see, buddy. What did you get? Liberal. That's tough. But he's looking pretty good, though, so who knows? Maybe I'll turn liberal, too. If he's a liberal, I'm a liberal. That's what they say, I think. And I just want to end the video by showing you something very interesting. Now, I will preface what I'm about to do here by saying that the neural net was trained only on politician faces. It wasn't trained on animal data. But, of course, I have to show this because it's too good not to show. Okay? So check this out. So I've got this photo of a bear here. And, you know, bears are big and strong, and they're the king of the jungle, really. I guess not the jungle. The king of the boreal forest. And look at that, bear's conservative. But, however, if we look at a picture of a cute little dog, dog is liberal. That's tough. Conservatives 1, liberals 0. Alright, thanks for watching.